Yes, good afternoon, everybody. Welcome to this session of sustainable construction methods. Today, we'll be seeing this topic of cable stayed bridge, which is the Bandra Worli ceiling. Let us see the case study, how this was constructed. And you can see here, this is the link which has been with the yellow line. You can see here, this is the yellow line, this is the ceiling. The most important part is this part where the cable stayed bridge has been erected here. This part, you can see this red lines here. This part, you can see this water body. This is the whole water body. Over this ceiling has been constructed. Let us see the map here. You can just see this map here. You can see this part. You can see alignment plan. This is basically the alignment plan at this place. You can just see this Bandra cable stayed bridge. You can see at this part, you can see Worli cable stayed bridge. So basically this is the part which has been constructed here, and this is the alignment plan. Let us go further. You can see this is the Mahimbe. All this can be you can understand. Most of you have gone here, they can understand these parts. Basically we are not related to that. Let us see how they have been constructed this part. Let us see the bridge details here. The length of the sea link is 5,600 meters. It is a big ceiling. Length of the cable stay portion. Now, what is the length? The whole ceiling is 5,600 meters. The length of the cable stayed portion is 600 meters. So basically, the cable stayed bridge will be constructed for 600 meters. Height of the pylon which has been taken, or the tower, is 123 meters. This is 123 meters, the height of the pylon. And the number of piers which will be erected is 620 piers. 620 piers. So you can just imagine how big the height of the pylon is, and the longest span is 2 into 250. Basically, this 600 this meters have been again divided into different spans. You can see the longest span of 250 meters. You can see a location of cloverleaf interchange at Mahim intersection and a flyover at the Lower Groove intersections have been proposed as part of this project to enhance the fast and safe traffic dispersal. You all must have seen the cloverleaf intersection, basically, which they are constructed at places of highways, so that the easy flow of free flow of traffic can be taken place where there are no obstructions. You can see the client is MSRDC and the main contractor is HCC. Total project cost is 850 crore. So it was the schedule in initialization and completion was from May 99 to May 2002. So basically it was for about 3 years. Actual completion took place in August 2009. You can just see the delays which have caused. The amount of construction uses 0.2 million concrete. This is the amount of concrete. See, this is the amount of concrete used. It was 0.2 million cubic meter. This is the amount of concrete which has been used. You can just see this subsurface explanation. Basically, before going for any construction, we go for geotechnical investigation. We need to see what type of soil is underneath. So after removing the soil, we go for investigation. You can see marine soil with silt clay is there. Marine soil with thick boulders is also there. Transported calcareous soil is also there. Weathered rocks are there. Basalt and volcanic tuff. So all these. So because we want to go for construction of the piles, we have to insert piles. So basically, we'll be seeing till beneath to a deep excavation has been done, and we are seeing what different types of soils are there inside. 25 boreholes along the length to obtain the soil profile. You can just see a 25 boreholes have been done to just remove the soil profile to understand what is the soil type and what is the investigation reports. You can see the substructure construction. The piling type of piles are combined end airing and friction piles. So this is the types of piles which have been erected here or constructed here. Diameter of the pile used is 1.5 to 2 meters. So this is the diameter of the pile, and the depth of the pile is about 5.15 to 663.4 meters. You can just imagine here how deep the piles have been inserted inside. Pile group under the pylon is 40 numbers. You can just see here the pile number of piles under the each pylon or the tower, different towers, is about 40. So 40 piles have been inserted inside. Construction type, you can see board cast inside too, or it was board, it was done on site. Okay, technology used for reverse circulation drill. Reverse circulation drill was the technology. Support structures of cofferdam and sheet piling. So basically over this piles, what was erected is that was the sheet pile. You can see the pile cap thick is about 3.5 meter. Once the piles are inserted inside, over them the thick cap is about 3.5 meters thick. The concrete uses M60. You can just see the grade of concrete. It is M60 grade of concrete, and the pier length is 4.6 meters depending upon the gradient of the bed. So depending on the gradient of the bed, the type of the pile has been inserted. You can just see how big the piles are. At some places it is 5.15, and at some places it has gone up to 663.4, and basically the diameters and everything has been mentioned here. Let us see here. You can just see type of drive and cast inside to pile. You can see this cross section, how thick is this. Is 100 thick PCC 1:4:8. As I have told you, it is M60 pile cap. You can just see here 8 numbers, 20 diabars. 8 numbers of 20 diabars are here, and at the and this which has been marked here is 8 8 8 dia bars at 150 continuous tie spiral 8 dia. Okay, fine. You can just see the this is the distance, or this is the spacing. You can see it is 150 now from here to here. You can just understand 8 dia at 150 continuous spiral ties. You can see 8 numbers dia. You can just see this cross section, 8 numbers of 2 to 20 diabars, 20 diabars. So basically this is the type of 15 cover. Also you can see a 15 cover has also been provided. So this is the type of pile which is inserted inside, and above that pile you have this pile cap which has been casted here. This is the type of pile cap. It was 3.5 meters thick as it was mentioned here. Let us see further. Coffer dam construction, a temporary watertight surface to facilitate construction of project which are submerged. So what is this type is basically what we are doing is, you can just see here from the sides basically we are trying to stop the water from this side and till our construction is can be completed. You can see the piles here erected. This is how over that. Then again we'll come for the main structure. It consists of casings of 1.5 dia and sheet piles. You can just see here, you can just see this casings. This is how the water, because where there are where there is a we have to stop the water and do a construction, this type of construction takes place. Just see this piling, how it is dual water drill pipe. You can just see a center sample hammer is there, well crowd see hole. This makes the hole. This is the hammer here. Cyclones sampling. You can just see it. This is how it gets entered. Once the coffer dam is constructed, water is pumped out. So basically, first the coffer dam is constructed, then the dam. What is the dam? Basically, it stops water. So basically, we build a coffer dam around a place where we have to go for piling. Then the water is pumped out. Dewatering technique adopted was well point system. This was the dewatering. Once the coffer dam was made and the water was stopped from coming inside, then the water was dewatered. Water was removed. Piling technique used was reverse circulation drill. You can see in this method, precast segment is placed on soil and drilling is done with the drill bit. So precast, basically it is drilled, then the precast segment which has already been constructed, it is sent inside. Sent inside. Let us see. Drill bit consists of pneumatic piston. You can see the drill bit which has used. Can you imagine just big drill? It is a very huge drill. You can just see here. Uh, Depth achievable is 500 meters. This drill bit can go up to a depth of 500 meters, and the bit dia is 13 to 20 centimeter. 13 to 20 centimeter dia is the bit. Material is tungsten steel. Output is 900 to 1150 CFT. You can see here. RPM at 350 RPM runs per minute. You can just see here. You can just see here. This is the coffer dam. Okay, this is the coffer dam, and it was built here first. Then the before going for piling, the water it was dewatered, and now the piles are being set up. They are being inserted inside. You can just see this picture. You can understand what I was trying to explain. You can see here after this coffer dam was made, and this pile has after the pile have been inserted inside, this is the base and the pier which has come here. This is how it was constructed. You can see here the water is removed, dewatered, and this construction has taken place. You can just see here, this is how the bridge is resting here. This is how the bridge is resting on the pier. You can just see this supports which have been given here, bottom supports. This thick plates, you can see the thick plate, basically they support the load coming from the top of the you can see here Let us see the side view. Pylon construction, how the pylon construction takes place. Cable anchor zone, 10 lifts. This is how. Upper tower legs, 24 lifts. And this is pier table. This is the pier table. Lower tower legs, 8 lifts. 8 lifts. This is 8 lifts. You can see the side view of the tower is P19 for Bandra cable. This is the side view, how it looks. Basically, this is the piles are inserted, then the pile caps are set on top of that. Above that, these piers come, and over this the pylon construction takes place. You can just see the height of the pylon. As I told you, it is very huge with a very big size. Lower pylon construction, you can just see it is constructed in segments, different segments. This is the lower segment, and then the upper segment comes up. Lower pylon consists of pier table, lower pier legs. You can just see this. This is the pier table, and this is the lower pier legs. Construction method used is self-climbing from construction. So construction is done in lifts. You can see 6 lifts required for construction of lower pylon. So 6 lifts are required here for the pylon to be constructed. It is done in stages. Lower segment is first casted, and then the upper segment is erected. You can see the pylon legs. This is the piles. You can see these are the number of piles which have been casted here. Over this, the pylons are then stayed erected on this. The pylon foundation, you can see this is the type of pylon foundation. You can just see this upper pylon. While constructing the upper lower leg, the care which was to be taken is the reinforcement doesn't fall due to its self weight. The self weight, the basic what care should be taken is the reinforcement. Because of the weight of this tower, it shouldn't fall down. This should be seen here. This care should be taken because the self weight is very high. There are chances while erecting it can fall down. So that is why embedded tubes were fitted in jump form to provide extra supporting legs. So just these tubes have been fitted here so that these legs doesn't fall down because of self weight. So this happens while erecting such uh, because of the long height of this pylon. This happens sometimes. This care should be taken. You can just see here the construction, how the reinforcement has been set up here. You can just understand by seeing this picture. The base has been erected, foundation has been erected. Over this pylon is to be constructed. You can just see this reinforcement, how the reinforcement is. As it had been explained in the previous slides, that the 20 mm dia bars are erected here. They have been placed here, and rest of the bars you can just see here how they are shown. Just see that the concreting of pile cap was done in 4 lifts with 3 pumps. 3 pumps were needed to concrete this pylon cap, only the pylon. Lower leg reinforcement was tied with starter bars at location. You can see here the lower legs, how they were casted. You can just see here this part is constructed in stages, as I have told you. That can be done. First lift shuttering for lower leg was done using formwork. Then the protruding reinforcement were covered. You can just see here all these. Just see. Let us see this construction first. So reinforcement were covered during monsoon season. During monsoon season, these reinforcement was covered because it couldn't be complete in a short span. So even that care had to be taken. You can just see this type. Tower lifts below deck were cast using fabricated steelwork. Already the fabricated steelwork was there, and they were erected here one by one, and this was completed in stages. You can see one lift in 2 weeks, and cycle team achieved in tower construction. You can see here it has been constructed here. Then the next cycle and the next stage was completed. You can just see this figure, how the pylon erection has been done. Tower lift was done using self-climbing formwork. You can see the type of formwork which has been used here. View of the P19 tower location. You can just see here the tower location. This is the top view uh, where the coffer dam had been erected, and the piles had been casted, and the pile cap had been casted. Over this, the pylon has been installed. You can just see here concrete core is taken out and tested for its strength. Yes, yeah. Again, after casting, the concrete is being tested also. You can see the integrity test was carried out using log equipment, sonic log equipment. You can just see how thick the reinforcement is. This reinforcement is so thick. You can just see P27 and P30 tower location. There is 6 pile group was installed. You can just see the 6 piles here, and this 6 piles. Over this, the whole big cap comes up. You can just see this pylon which has been erected. This huge pylon which was completed in stages. It is completed in stages. Let us see the superstructure construction. In the superstructure construction, what happens is already the precast segmental construction takes place, span by span erection for approach span. So basically, what has happened is the substructures has been constructed. Now the superstructure is done in phases. You can see it is already precasted and it's got onto the site and it is erected here. Parameters for segment casting is alignment of the individual span to which segment belong, pre-camber necessary to take care of deformations of the girder due to self-weight. So there are chances of deformation, there are chances of deflection. So this care should be taken to reduce the self-weight. Pre-stress and other permanent loads. There are some loads which because of that there are chances of deformation. Necessary corrections for errors in the casting of adjacent segment cast earlier while match casting. So let us see this. You can see that the casting yard is there, which is close to the site. From here to the casting site, these segments are transported and fixed one by one. You can see the total number of segments are around 2500 and more. There are three types of segments in it. It is approach span segment, main cable stayed segment, segment on piers. So basically these are three types of segments which have to be erected one after the other. The size of the approach segment is about 18.1 meter into 3.2 into 3 meters. This is the size of the approach segment, and size of main cable stay segment is, it is about 20.8 meters into 3.2 meters into 3 meters. So basically approach segment and then the main cable segment is there. Weight of the each segment is about 150 tons. This is the weight of the each segment which is coming, which has to be resisted by the piers. Total length of the casting yard is about 350 meters. This is the length of the casting yard where all these uh, units are casted beforehand. Capacity is about 300 segments at a time. So it is such big, 300 segments at a time can be casted here. You can just see these pictures. The segments are placed in the casting yard. They have been casted. They are ready to be installed. Let us see here the erection of segments. This is how the erection takes place. The erection gantry does the erection of the span. The typical 150 meter span comprises of 15 numbers of precast segments. You can just see here one after the other how the segments have been arranged in a proper manner. The approach segment and the main cable segment, they have been uh, casted one after the other. This is how, and this is done with the help of erection gantry. Let us see, these segments are transported to the side with the help of barges. Each segment is lifted and all the segments in a single span are aligned together and brought about at the same level. You can just see how they are aligned one after the other. These segments are aligned one after the other and they are fixed together one after the other. You can just see the segments which have been precasted beforehand. They are fixed one after the other. Let us see this pictures. You can see here at the time of the match, casting high tensile steel rods are passed to the ducts provided in the segments and tightened with the help of a winch machine. Neutron BC solution is used so that the two segments can be aligned together. You can see each segment should be aligned properly. High tensile steel rods are passed through it and the ducts, and they are tightened together. You can just see this erection gantry, one after the other segments have been fitted here. You can see this. This is direction gantry Asian Hercules. This is direction big gantry girder. This is. You can just see here the erection of stay cables, uncoiling the cable on the bridge deck using as uncoiling unit and a winch. You can see the pulling the lower end of the cable close to the anchorage location with the winch, and then pulling the anchorage into position. Installation of the upper fixed anchorage using a crane and a deviation device, cable stressing and cable force adjustment by means of a hydraulic jack and lower end of the cable. So by means of the hydraulic jack, it is tightened. You can just see how the cables have been fixed here and slowly one after the other and how they are tightened using the hydraulic jack. The cable stayed portion is about 600 meters in overall length. It consists of about 250 meters cable supported main spans, flanked by 50 meters conventional approach spans. So about 50 meters of conventional approach spans is there. The center tower with the overall height of 128 meters is there above the pilot. So this is the center tower with the height of 128 meters. Pile cap level supports the superstructure by means of 4 planes of stay cables and a semi-fan arrangement. Different fan arrangements had been shown earlier. Cable spacing is about 6 meters along the bridge deck and are tied up to every alternate girder. The big tower is about, it has 264 stay cables. The length is, minimum length is about 85 meters and the maximum length is about 250 meters. Small tower, it has 160 stay cables and the length is about minimum is about 30 meters and the maximum is about 80 meters. Uh, and in each segment there are approximately 135 strands stressed with the help of a hydraulic jack. With the help of a hydraulic jack, they are stressed here. Let us see here. You can see the different types of shapes. It is triangular one is there, and how it is angled here. You can just see this here. Yes, let us continue with this. We were here, we were seeing the description of the shapes, how the shapes were here. Yes, let us see here. Let us continue from here. We'll have seen the different types of pylons, what in the segment. We have already seen all this. We were here. Description of the shapes. You can see here the triangles are one of the shapes used by the attachment of the cables and the beam. This shape is used because of its ability to transfer the tension. So this type is taken because it can transfer the tension as the moving load goes across the bridge. So this is how the load is transferred because of this type of arrangement. In this bridge, you can see the distance of the cable up the tower is equal to the distance from the tower to the connection point. So this distance is equal. You can just see this red line marked here. This distance and this distance is equal to the connection point on the beam and is 90-degree angle. You can just see this distance is proper and this distance. Here the cables have been uh, erected here. So this is how, and this is the how the tension can be distributed. Load and tension can be distributed. Triangulated bracing between the cables reduce the amplitude of oscillations. The number of oscillations will also reduce because of this type of connection. A rectangle is attached at the convergence point of the beam and the tower for stability. This is the rectangular type, and this is for stability. It is provided for stability. You can see here the continuity PT and grouting. Once the deck is complete, post tensioning of all the segments is done so as to bring them to a specific predetermined geometry. This is done with a post tensioning because everything is casted inside. Once they are pulled with using the hydraulic jack and they are tightened. The grouting of the bridge includes a major task of fill up the space left in the holes for the PT cables. Yes, for the PT cables, space is left and that is filled using the grouting grout. It is filled with the grout. So this is how the grout once the it is tightened using the hydraulic jack, then it is filled. Those spaces filled using the grout. Cable force adjustment and fine iterative process. It is iterative for last stage. It is the last stage where everything is tightened properly. Rechecking of tension forces in each cable so as to confirm that it equals the forces. It is rechecked again whether the forces are distributed properly or no. 1 to 2% of variation is allowed. Nothing more than that is not allowed. You can just see the benefits of the Bandra Worli ceiling. What was the benefits? It is estimated that the ceiling will help saving rupees 10 million annually. You can just see how much amount of money can be saved here due to congestion in the traffic and length of the previous route and shorter new route. So it provides a very short route, and the amount of savings it can done is about rupees 10 million annually. While earlier it used to take about 40 minutes to drive between Bandra and Worli, now the distance can be covered in mere 8 minutes, resulting in large savings in time. You can just see what a huge difference from 40 minutes to 8 minutes. This can be covered just in 8 minutes. Just see the amount of time it can be saved and the amount of money it is also saved, and the economy can be generated. So this is the biggest advantage what we have got using this link, though it took a lot of time and the cost was very huge. 850 crores we invested here, but every year it can save about 10 million annually. You can just imagine here what it can save. So this was the case study of Bandra Valley sailing. Hope it was beneficial to you. I request all of you all to please go through the session and please comment in the comment section. Thanks a lot.